Good morning and welcome back. Welcome to our online classes, student. Here, as you know, we are working with our Boolean Algebra chapter, and from today we are going to start a new section of this chapter. The section is related with laws of Boolean Algebra. Boolean Algebra, it is a branch of mathematics. It is just same as our arithmetics, or we can say it is related with our mathematics. So in mathematics, laws are there, theorems are there, the same as in the algebraical arithmetics. We are having some laws in Boolean algebra also. We are having some theorems in Boolean algebra also. Now the point is, in Boolean algebra, just keep in mind that there are only two values, 0 and 1. The whole Boolean algebra developed on these two base values only, so that it is related with binary number system. Clear? So, what are the rules in this Boolean algebra? In today's video lecture, we will discuss about these laws. Clear? So very first law, yes, the thing is, all these laws are related with the fundamental gates of Boolean algebra. Fundamental gates mean AND gate, laws are related with OR gate, laws are related with NOT gate. Only three fundamental gates are there. So on the basis of these fundamental gates, these Boolean laws are developed. So very first law, it is known as property of 0. Two values are there only. First one is 0, second one is 1. So what will happen if we apply 0 as an input signal to each and every fundamental gate? What will happen? Just check it out. Now here, it is the AND gate of Boolean algebra. In this AND gate, the first input is A and I am going to supply the second input as 0. Here, it is known as property of 0. We are going to check what is the result if we apply 0 in all these three fundamental gates. So here, it is AND gate. AND gate works on binary multiplication. When all the input signals are 1, then only the AND gate produces result as 1. Otherwise, it will show 0 result. So here, A, 0. Now, the input signal A, for A there are only two possibilities. Either it is 0 or it is 1, because two values are there only. Clear? So, A and 0. Now, what is the result over here? If we multiply 0 with 0 or 0 with 1, what will be the result? The result is 0 only. It is binary multiplication. So we can say A dot 0 dot, because it is AND gate. Right? First input is A, second input is 0. When any one of input signal is 0, the result is 0 automatically in the AND gate. So here A dot 0 equal to 0, it is known as the property of 0. Now the same thing, if we apply this 0 with this OR gate, now check what will happen. First input is A, second input is 0. Now the possibility of A, either it is 1 or it is 0. Two possibilities are there for it. Now 0, 0. What is the result? 0 plus 0, the result is 0. Now 0 plus 1, what is the result? It is 1. Means, when the value of A is 0, here the result 0 plus 0 equal to 0. When the value of 8 is 1, here the result 0 plus 1 equal to 1. Means the result is totally depend upon the value of A. So we can say A plus 0 equal to A. It is there in our general mathematics also. 5 plus 0 means what? 5. 10 plus 0 means what? 10. So A plus 0 means what? It is A. Here plus indicates OR gate. Clear? Now come here. If we give 0 as an input to the NOT gate, it is the inverter. 0. It inverts 0 into 1. Two values are there only, 0 or 1. So if we supply 0, the output is 1. So we can say 0 bar equal to 1. Right? It is known as the property of 0. Property of 0 means a dot 0 equal to 0, a plus 0 equal to a 0 bar equal to 1. Right? Now the next one, property of 1. What is there in this property of 1? Just check it out. Here in this property of 1, we are going to supply 1 as an input signal to each and every gate. Now very first, if we supply 1 into this AND gate, just check the diagram. A, first input is A and the second input it is 1. So what will happen? First input is A, second input is 1. Now here, two possibilities are there for this A. Either the value A is 0 or the value A is 1. So 0 into 1, result is 0 into 1, result is 0. Now if the value A is 1, 1 into 1, result is 1. So here we can say A dot 1 equal to A. The result depends upon the value of A. If the value of A is 0, then the result is 0. If the value of A is 1, then 1 dot 1 result is 1. Right? So A dot 1 equal to A. Now if we supply this 1 into this OR gate, A plus 1, plus means OR gate, A plus 1. Here you just remember the rule that are related with OR gate. OR gate says if any one input signal is 1, then the overall result of this OR gate is 1 only. Just check the truth table that are there in this OR gate. We have created one truth table in the OR gate concept. Just check this truth table. If any input signal is 1, then the overall result is 1. So A plus 1 equal to 1. Clear? Now, if we are going to supply 1 in the NOT gate, what will happen? 1 inverse of 1 means 0. So 1 bar equal to 0. Right? So these 6 different rules are here on the board. First one is property of 0. Second one is property of 1. You have to remember each and every rule so that you can solve the Boolean equation. 1 2 marks question is there in the question paper. The question is related with to solve the Boolean algebra or to justify this particular Boolean law. Right? For justification, we require these necessary things. Now come here. Property of inverse. What is there in property of inverse? If two NOT gates are there in a circuit, now we are going to check what will be the result. Two NOT gates are connected with each other. If I supply 1, then this NOT gate convert 1 into 0. Just check it out. 1 into 0. So first NOT gate convert 1 into 0. Then again the second NOT gate, here the input signal of the second NOT gate is 0. It converts 0 again 1. So we can say 1 bar, 2 different bar means presence of 2 different NOT gates. So 1 bar result is 1. Here we can say A bar result is a means. In any Boolean equation, if you see the same size bar on any Boolean equation, A plus B, it is a Boolean equation, and 2 same length bar is there. So these 2 bar can cancel each other. Here you can cancel bar to bar and the final result is A plus B only. Check it out. A bar means A plus B whole bar means what? Bar to bar cancel. The result is A plus B. Right? So these 3. Property of 0, property of 1, property of inverse. 3 rules are here, 3 laws are here on this board. Now come to this part of the board. Here again 3 different Boolean law is here. The first one, idempotent law. What is there in this law? What will happen if we supply to same input A, both the inputs are same, to same input to AND gate and to same input to OR gate, what will happen? So A dot A, the result of this one is A. If you want to check it out, suppose the value of A is 0, right? So here it is 0, 0, 0 into 0, what is the result? 0 only. A dot A equal to A means the value of A is the result. Now just I am going to convert the value of A is 1. Now check it out. What is the result? Here it is 1. Here it is also 1 because both the input are same. So 1 into 1, what is the result? It is 1. Means what? A into A dot A equal to A only. The same thing is here in the OR gate, means A plus A, it is also equal to A. Right? So here it is, the another rule of Boolean algebra. A dot A equal to A plus A equal to A. Now come towards the complementary law, the most popular law of Boolean algebra, complementary. Complementary means we supply two different input to the gate. The first input is the input signal and the second input, it is the invert of this first input signal. Means what? A bar. Right? First input A, second input A with NOT gate means what? It is A bar. Or instead of that I can use A bar over here. Now, if the value of A is 0, what is the value of A bar? It is 1. So first input is 0, second input is 1. What is the result? Overall result is 0. Proof. Now, if the first input of A is 1, what is the second input? 1 inverse of 1 means 0. So 1 into 0, the result is 0. Right? So here we can say A dot A bar equal to 0. Dot means AND gate. A dot A bar equal to 0. Now the same thing in OR gate. A bar with in this OR gate. Suppose the value of A is 1. So here the value is 0. 1 plus 0. OR gate, any one input signal is 1, result is 1. So here what is the result? It is 1. Now change the value. Value of A is 0 and here A bar means 1. 0 plus 1. Again the result is 1. So complementary law says A dot A bar equal to 0. A plus A bar equal to 1. Clear? The next one. Commutative law. Commutative law means A plus B. You can write it as B plus A. If you change the sequence of the input signal, there is no harm in the circuit, there is no change in the circuit, such as if AND gate is there, my first input is A, my second input is B, now the result is A dot B. If I convert these two input signals, such as अभी मैं B को ऊपर लगा देता हूँ, now B is here, A is here, now the result is B dot A. Both the results are same. There is no rule, there is no conflict if you reverse the input signal. So we can say A plus B is equal to B plus A. A dot B is equal to B dot A. Right? So here on this board, 6 different laws are there on the board. Just remember all these laws so that you can prove any given Boolean equation either algebraically or according to the truth table. Right? Thank you very much. Now, 3 more Boolean laws are there on the board. The first one, it is associative law. What is there in associative law? The second one is absorption law. And the third one, it is a distributive law. These 3 very important laws are there in Boolean algebra. Now we will discuss what is there in these laws. The first one, associative law. The associative law, it is related with the same gate. Same gate means what? Just see the first associative law. A plus B plus C. Plus same gate is there. Now, if same gate is there in the equation, then it is on you that either you can change the bracket from here to here. Means you can shift the bracket. A plus B plus C, it is same as A plus B plus C. Right? First, A plus B plus C means what? First you are going to solve B plus C. Then the result is going to add in A. It is same. If you solve A plus B first, then add the result into the C. Right? And then if this law is true, it means the dual of this law is also true. Just remember the previous lecture, principle of duality. In this lecture, we will discuss about we can convert plus with dot, dot with plus. Right? So here, if we want to convert the dual of this law, plus, put dot instead of plus, so it is A dot B dot C. right? Equal to plus means dot dot a dot b dot c, means if it is true, then the dual of this equation it is also true, and it is known as the second law of Boolean algebra, right? According to the principle of duality. Now come towards here, absorption law. Absorption law says a plus a dot b equal to a, right? It is a law. A plus a dot b equal to a. Now we are going to prove this law either by using truth table method or by using algebraically method. Clear? Now the second law, if this law is known as absorption law, then the dual of this law means plus into dot, dot into plus, it is the dual. Here the first law and the second law, it is based on the dual of that equation, means both the laws are under the category of absorption law. Now the thing is, the question that comes in our CBSE pattern, justify the absorption law or justify and verify the absorption law, or the question is prove absorption law of the Boolean algebra, right? So how to prove that law? Here we are having two methods. The first one is truth table method and second one is algebraically method. How to prove that law? Suppose the first law I am going to prove it by the help of truth table. Then first find out how many inputs are there in this equation. Two inputs are there only. First is A, second is B. So I am going to create the truth table of this equation. First is A, second is B. Right? Two inputs are there, means total possibilities are 4, 0, 0, 0, 1, then 1, 0, then 1, 1. 4 total possibilities are there. Now, precedency says I have to solve NOT gate first, then AND gate, then OR gate. Here, no NOT gate, then the second precedency level it is of AND gate. So I am going to solve A dot B over here. A dot B, what is the result? A dot B, 0 into 0, 0. Here 0, 0, 1 into 1, 1. It is the result of A dot B. Now, A plus A dot B what? It is the left hand side of this equation, A plus A dot B. Now, A plus A dot B, it is the column of A, it is the column of A dot B. A plus A dot B, it is 0. 0 plus 0, 0. 1 plus 0, what is this one? It is 1, then 1 plus 1, it is 1. This is the left hand side of this equation. I am going to shade it out. Now it says A plus A dot B equal to A. Just select the column A. A 0, 0, 0, 0, 1, 1, 1, 1, hence prove. A plus A dot B, it is same according to the column A. Just check the value. So the theorem is hence proved. Clear? Now, if we talk about algebraic method, how can we prove a law algebraically? I am going to take the second law. The law is A dot A plus B equal to A. It is the law, right? Very first I am going to take the LHS part. LHS part means A dot A plus B, right? I can convert this line as, I am going to open the bracket. Once I am going to open the bracket, I am going to divide all these input signals with A. So the first line, the solution is A dot A plus A dot B. What is A dot A? A dot A, just see the previous board. A dot A means A. So here we can write it A plus A dot B. Clear? Now A plus A dot B, if I am going to take A as a common, then what will happen? Then it is A is common and here it is B plus 1, right? A is common, remove A from here, 1 plus B. So 1 plus B, it is the next point. Now what is 1 plus B? OR gate. If one signal is 1, overall result is 1. So here we can say A dot 1 means what? The result is A, hence proof. Clear? It is the algebraical method, it is the truth table method. You can solve the law according to your style, according to your concept, which one is beneficial, which one is easy for you. Now come to the last one, distributive law. Distributive law says A dot B plus C equal to A dot B plus A dot C. Right? I am going to prove this first law by using truth table. So how many inputs are there in this equation? 3 inputs are there, A, B, C. I am going to take these 3 columns. The first one is A, second one is B, third one is C. Right? 3 inputs are there. It means total number of possibilities are 2 raised to 3. Means what? Means 8. Total 8 different possibilities are related with this equation. Right? So I am going to draw 8 different rows over here. 1, 2, 3, 4, 5, 6, 7. And here it is 8th row. Clear? Now the inputs 0, 0, 0. Just draw the octal table. 0, 0, 1. 0, 1, 0, 0, 1, 1, then 100, then 1, 0, 1, 1, 1, 0, and the last one is triple 1. Now, very first, if we solve the LHS part, this one, so here B plus C, I am going to create one more column that is related with B plus C. B and C plus means binary addition, 0, 1, 1, 1. Here it is 0, then 1, then 1, then 1. The result of B plus C. Now I am going to find out the overall LHS. It is A dot B plus C. B plus C column is here. I am going to multiply this column with A. So A 0 into 0, 0, 0 into 1. Here it is 0, 0 into 1, 0, 0 into 1, 0, then 1 into 0, again 0, 1 into 1, 1, then 1, then 1. It is the result of A dot B plus C. This one is the left hand side of the first equation. This one, I have solved this one. Clear? Now come here on the RHS side, A dot B plus A dot C. Very first I am going to draw A dot B. So A dot B, this column. Next one I am going to solve A dot C. Then I am going to solve what is there in A dot B plus A dot C, right? A dot B means these two columns you have to multiply it. 0, then 0, 0, 0, here again 0, then 0 and last 1, 1. A dot B. Now A dot C, 0, 0, then 0, then 0, 0. Here it is 1, here it is 0 and here it is 1. Now A dot B plus A dot C means you are going to add these two columns. 0 plus 0, 0, then 0, 0, 0, 0, 1 plus 0, it is 1, 1 plus 0, 1, 1. Clear? This is the right hand side portion of the equation. Now just going to match LHS and RHS, both are equal or not. It is LHS. That is RHS, 0, 0 equal, 0, 0, 0, 0, 0, 0, then here 1, 1, 1, 1, 1, 1. LHS equal to RHS means with the help of truth table, we proved that this A dot B plus C is equal to B dot A dot B plus A dot C. Here the law is proved. It is HP. First law is proved. Right? Now, if you want to prove the law by using algebraic method, what you can do, just check it out. I am going to rub it down. Now the second distributive law we are going to solve with the help of algebraic method, right? So the second law is A plus B dot C equal to this one. It is the second law, right? I am going to take right hand side first, this one, and I am going to convert this right hand side into left hand side, right? So very first we have to write the law. It is A plus B dot C equal to A plus B dot A plus C. This is the law. Now just take the RHS part here. RHS. Now what is there in RHS? It is A plus B dot A plus C. I am going to open the bracket, and once I am going to open the bracket, it looks like this one. Very first A A is multiplied with A and then it is multiplied with C. So it is A dot A plus A dot C. Right? Now B, I am going to multiply the whole bracket with B. So what is there? Here it is B dot A plus B dot C. This is the equation if I am going to expand both the brackets. Clear? Now A dot A. What is A dot A? We can write it. It is A. So A plus A dot C plus B dot A, or B dot A, I can convert the sequence also. It is A dot B plus B dot C. Right? Just take A common according to these two. A is common here. So here I can write A1 plus C. Right? And from this part I am going to take B as a common. Or just leave it out. The thing is there, A dot B plus B dot C. Now what is this? It is converted into 1 plus C means 1. So it is A plus A dot B plus B dot C. Right? Again, out of these two, I am going to take A as a common. So the line is converted into A is common. Now 1 plus B. And the next part is B dot C. 1 plus B means what? OR gate. One input is 1. So overall result is 1. So here we can write A plus B dot C. Just check it out. A plus B dot C. It is the LHS part. So here this law is also proved by using algebraic method. Okay. Thank you very much.